Welcome back to the Scotti-BYTE channel, and this is Scott. So 2026 is going to present some challenges for those of us who run home labs. And so I've entitled this one, Home Lab Cost of Memory. So all memory is produced by Samsung, SK Hynix, Micron Technology, and a little bit by Western Digital, and then in Kioxia in Japan. So Micron is planning to exit the consumer memory market in the end of February 2026. And there are two Chinese companies and two Taiwanese companies that are emerging chip manufacturers, but it's going to take a little while for them to come online. And then, of course, the big question is, considering the current tariff environment, will we even be able to import from China? So the top chip makers for right now, and probably for the near future, is going to be Samsung, SK Hynix, and Micron. And memory prices are climbing now due to tighter supplies, cyclic pricing, tech transitions, and most importantly, and the thing you've probably heard about, is the AI and data centers outbidding consumers for limited supply, because the chip manufacturers can make more from the enterprise customers than they can from individual consumers. So I've entitled this slide the Home Lab Scramble. In July of 2024, I bought Crucial memory, namely a Crucial 64 gigabyte kit. That was 2 sticks of 32, which was laptop type memory for my small Minisforum mini computers. And I bought those memories for $119 total for the 64 gigabytes. And that same memory today in January of 2026 is $400. And this situation also tends to affect storage as well, because as you know, the majority of storage being used today is going to be either SSDs or NVMEs, and essentially those are storage based on the same memory. So in November of 2024, I bought a Samsung 990 Pro, which was a 4 terabyte NVMe for $270. And I even thought that that was a bit expensive at the time. Well, fast forward here to January of 2026, and that same 990 Pro is now $549, and a week ago it was about $430. So in February of 2025, a Crucial 128 gigabyte kit, and I always wanted to go to 128 gigabytes on at least one of my servers. That is 128 gigabytes of DDR5 SODIMM, was $287. At the time, I didn't buy that memory because I said, well, I don't have a server for it yet. I'm just going to go ahead and wait. Well, it turned out that that was a mistake, because now in January of 2026, that same 128 gigabyte kit is $1,112. So in 2026 and 2027, it won't really just be price and prices going up and prices going insane, but we're also going to have massive shortages. And part of that is due to a run on memory, and part of that is due to the fact that Micron, who is the largest memory manufacturer, is going to be exiting the consumer market, as I mentioned earlier. So will this get better? And yes, Samsung and SK Hynix will bring new consumer memory manufacturing capacity online to solve this problem. However, don't expect consumer supply to recover until late 2027 or perhaps 2028. And this is pure economics. They sell to the people who pay more money, and the enterprise customers are paying more money, and translate that to AI data centers, which have a requirement for huge amounts of memory. So memory companies make more selling to large enterprises than they do to individual customers, and that's what this all comes down to. So what exactly did I do to take care of this issue? Well, I created a new server I call VMS Storm, and it is my new Inca server, and I did that for a variety of reasons that you'll see here shortly. I purchased a Minisforum MS-S1 Max, and it's probably one of the most powerful mini computers in existence today without going out and spending something like $10,000. So it's based on an AMD Ryzen AI Max Plus 395. It has 16 cores, 32 threads, and a max clock rate of 5.1 gigahertz. And it has 128 gigabytes of LPDDR5X, which can perform at 8,000 megatransfers per second. And that's referred to as on-package or soldered memory, and that's what that X means there. And that makes it non-upgradable, but it also makes it faster memory. So the 128 gigabytes of LPDDR5, 8,000 megatransfer per second memory has an advantage over typical DDR5 memory because it does transfers at up to 128 gigabytes per second versus 89 gigabytes per second. And so that makes a difference. Every time we take one of the subsystems, whether it's storage or it's memory, and we improve its speed, we get an overall net improvement. So memory can be dynamically assigned to the Radeon 8060S integrated GPU in the Minisforum MS-S1 Max, and that GPU has 40 GPU cores. So normally when we look at a really fast video card, we're looking at a video card that's got a lot of onboard memory. In this particular case, it's not using standard system memory, but it's using this LPDDR5X, and it's being dynamically assigned as is required. So this would really matter if I was going to go out and run something like Windows and use this as a desktop system, but my plan to use it as an Inca server won't make that particularly important, but there will be some situations where that really will matter, and we'll get into that as we move through 2026. So then this unit also has two 10 gigabit LAN NICs, which are Realtek RTL 8127s, and the Minisforum MS-S1 Max came out in around, I think, the November time frame. And it was only about 30 days before it came out that the Realtek RTL 8127 10 gigabit NIC came out. So it's a relatively new device. And as a matter of fact, it's so new that the drivers are not a part of Ubuntu, or they're really not a part of the Linux kernel, more aptly stated. And so I had to go ahead and search down the drivers and add them myself, which really wasn't that big of a deal, but it's just something interesting to note. A lot of people consider the fact that Linux operating systems don't need drivers. It's not that they don't need drivers, it's that the majority of the drivers are already integrated into the Linux kernel. So then it also has two USB 4.0 or USB 4 front panel ports, which operate at 40 gigabits per second, and it has two USB 4 version 2 ports on the back of the unit, and they each operate at 80 gigabits per second. So it also has a M.2 2280 2 terabyte NVMe that comes with it, and that is in a PCI Express 4.0 slot with 4 lanes of PCI And then we have a second M.2 2280 slot, but that available slot is only a PCI Express 4 X1 as opposed to an X4 slot. And then we have an internal PCI Express X16 expansion slot, but even though it's an X16 slot, it really only provides 4 lanes of PCI Express bandwidth. And it's pre-installed with Microsoft Windows 11 Pro 24H2. And don't even get me started. Boy, that was a challenge to try to get Windows off of this thing. So normally, if you get a machine that has Windows pre-installed, you simply just have to boot it up and turn off Secure Boot and turn off Fast Boot, and you're good to go, and you can install Linux or whatever operating system you want. This machine absolutely did not want to turn loose of Windows. I mean, it was unbelievable. It was like, I'm sorry, you're going to run Windows because Windows is the only operating system on the planet. So that was interesting, but I did get beyond it, obviously. So, hey, is this box crazy expensive from those specs so far? Well, it kind of is, and it kind of isn't. And this is the MSS1 Max sitting on top of my rack. I just thought that was a better location for it. The only cables I have plugged into the rear are the power cable and a 10 gigabit Ethernet NIC. And so what's interesting also about this unit is that it does not have a power brick. The power supply is actually internal, which is kind of nice. So it's larger than most mini PCs, but as you can see, it's not particularly huge. So what are the real costs of using something like this as opposed to using something else? Well, in January of 2026, this was a $2,919 server / desktop, or whatever you want to call it. But it has a killer AI processor and 128 gigabytes of LPDDR5X. And when the unit was first announced, it actually went up for a sales price of about $2,600. So in the last few months, due to all this craziness in pricing, it's gone up $300, $350 or so. So the Ryzen AI Max Plus 395 that's in this unit has 16 cores and 32 threads, and it outperforms the processors, the predominant flagship processors that we've seen as AI processors by several companies, which are based on the Ryzen AI 9 HX370, which has 12 cores and 24 threads. The other thing that's interesting to point out about the MSS1 Max with its Ryzen AI Max Plus 395 is that it has 64 megabytes of L3 cache as opposed to the Ryzen AI 9 HX370 base machines, which have 24 megabytes of L3 cache. So yet another place where it has more capacity and performance. And the Ryzen AI Max Plus 395 really shines in multi-core tests. Not quite as much in single-core tests, but then and again, if you buy a machine like this with a lot of massively parallel cores, the whole idea is to be able to do multi-threading and multi-processing types of applications. So the Minisform A1 X1 Pro 370 with 96 gigabytes of memory, or 96 gigabytes of, I would say, conventional DDR5 SODIMMs sells for $1,500. Well, not a bad price, and really a pretty decent processor when it comes down to it. And don't get me on the bandwagon of AI in general, because even though all these machines are sold as AI machines, the only real true AI applications that we're seeing in bulk out there right now are ones that are based on running on GPUs. The ones that are running on these AI processors, I think we're going to start to see a lot of those applications being released in 2026. And in fact, if you go out on GitHub, you're starting to see a lot of development related to that. And so, as mentioned earlier, the 128 gigabytes of crucial DDR5 5600, the SODIMMs that is, sells for $1,112. So that's pretty pricey. And unfortunately, if you were going to go out and buy something like the Minis Forum A1 X1 Pro 370, they don't sell those bare bones. And if you look at a lot of the other manufacturers that sell mini PCs with that same type of hardware, that same CPU, you're going to find the same problem in that they will typically sell one with 64 gigs or 96 gigs, but not 128. And so from the get-go, one of my goals was I wanted a lot of memory because I'm going to have some large memory applications, and I didn't want to fight with inside the typical 64 gigs. 96 was better, but hey, let's face it, 128 gigs is better, especially when it is this faster integrated LPDDR5X. So what exactly did I do? Well, I installed a PCI Express X4 NVMe controller in the expansion slot of the MS-S1 Max. And that was so that I could have a by 4 processor instead of using the second by 1 slot. So that's what I was doing. And when I added that expansion card, I went ahead and populated it with a Samsung 990 Pro 4 terabyte NVMe, and it became a dedicated ZFS storage pool for Incus, because basically this thing is serving as a giant Incus server. So I installed Ubuntu Server 2404 with Incus with pretty much the similar type of procedure that I show in Incus Container step by step, with bridge 0 and the bridge profile and all that, and everything worked fine. I reproduced a lot of my profiles, and I just did basically Incus move commands to move existing containers from the old systems to the new system. And so what exactly did I move? Well, I didn't move everything. I kind of just moved some selected things. So I connected one of the Minis Forum MS-S1 Max 10 gigabit NICs to my Unify USW Pro 48 PoE switch on SFP plus port number 51 with an RJ45 SFP plus module, and that's how I got my 10 gigabit connection to this new server. So this slide is entitled Now What? And if you look at the very top here, you can see this is Lex Console looking at the Incus containers on the new machine. So I had VMS Mist and I had VMS Rain. This one's VMS Storm. And so it just seemed like Storm was a little bit more appropriate for this killer machine. So far, I've moved over 11 regular containers and 3 VMs. The 3 VMs include a Windows 11 25H2 VM with 16 gigabytes of memory. And the 11 containers, I moved some of my infrastructure containers over. So I was starting to have performance problems with my 75 containers running on the 2 small Ryzen 5 Incus servers that I had. And namely, one of the things that would happen is I think that even though I had enough memory, I might not have had enough CPU cores, because when the system started running more severely, I would have some outages related to Nginx Proxy Manager, and it was causing my hosted services to go offline. And I was noticing things like periodically my discourse server, discussion.scotti-BYTE.com, would go offline. The Rocket Chat server would get interruptions at chat.scotti-BYTE.com, which is where you guys should be coming to have discussions as opposed to trying to enter a novel into the YouTube comments. And so that was all fine and dandy. And if you look down here, it says, hey, this is an MSS1 Max, has 128 gigabytes of memory. The CPU count is 32 because Incus Lex Console goes ahead and adds up all of the cores, and that's what it comes up with when you start looking at the threads. And then it calls out which processor it's got in there and what video card it's got in there. And then at the bottom left here, you can see the standard NVMe it comes with is a Kingston 2 terabyte NVMe. And that's where I've got one other storage pool that I use for some specialty things and a couple of other applications. I'm going to add some other things to it, but that's really where the root operating system is running. And then this NVMe 0N1, which is the Samsung 990 Pro 4 terabyte unit. That's the 4 terabyte unit there, and that particular unit is is in that expansion slot that we mentioned here earlier. So what about the Scotti-BYTE channel in 2026? What's happening? Well, my existing two Minisforum Incus servers had 64 gigabytes of memory each, and they've served me well, and they will continue to serve me well. And so they have Ryzen 5 3550H mobile processors, which have 4 cores and a total of 8 threads, 2 threads per core. And I was hosting a total of 75 containers on these two devices, as I mentioned earlier. And I needed some better performance to correct these NPM interruptions in service. And I really wanted 128 gigabytes of main memory without a power-hungry rack server that generated excess heat. Considering where I live in Texas, it's hot enough. And as it is, I have lots of cooling in my computer room, and I even have to use it during the winter to keep that room from turning into a sauna. So most importantly, I want to implement more AI apps in 2026, and the Ryzen AI Max Plus 395 gives me almost unlimited options, and that was really going to be key in my selection of that machine. So in summary, the next 2 years will not only be much more expensive for memory and storage as well, but the availability is going to be a huge issue, and that's because of the run on the market and also the number of consumer items that will actually be manufactured and available for purchase. And my advice is either buy now or decide that you're going to wait 2+ years for this to get better, because I think that's what we're looking at. And self-hosting still gives you ultimate control over your data, and so I would always say self-host. But it's likely that the cost of VPS, that is virtual private servers or virtual public servers, depending on how you want to call it, hosting in the cloud will become more expensive as well. And one of the reasons for that is because it uses the same resources. And even though those resources are purchased by enterprise data centers, when they're resold, the price of memory is not only going up for the consumers, but it's also going up for the enterprise as well. So let me know what topics you would like for me to cover in 2026. And that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.